everybody. Thanks for the opportunity to present at the conference. It's rather late in India now. It's 1:30 a.m. So yeah, might not be the best of time for me to present, but I'm looking forward to share our thoughts with you. This is about building bilingual LLMs frugally, and I'll try to explain what these things mean as we go along. And you have this little picture that'll give you a sense of what it is. It's a llama with an elephant. We call this series of models Open Hathi. Hathi in Hindi means an elephant. And it's meant to be an open source effort to support Indian languages in existing open weight LLMs. I think the previous speaker, Stitch, was already setting the stage for various things, so I don't have to discuss many things in detail, but let me use a combination of the slides and a note we have written to explain to you the overall problem. Of course, we are all in this crowd very familiar with things like Llama and Mistral and how these open weight models are creating innovation. But it turns out that they don't have support for Indian languages. So if I actually give it a sentence in English and ask it to translate it, Llama 2 and Mistral both can generate something that looks like Hindi. These are Devanagari script responses, but they turn out to be wrong. GPT 3.5, on the other hand, which is, of course, a closed model, does a reasonable job. Right? So that is the first thing. It would be good to have in these open models, which are being used so extensively to build upon, support for Indian languages as well. The other challenge, of course, is the data. I think Sitish mentioned about using, 50 or 60 billion tokens for Hindi. And there are repositories in Hindi that have that kind of data. But in various experiments that we did, we found the quality of that data, not that particular data, but in general, the data that's available on the web. We had an effort called Sangraha, which is to curate Indian language content on the web. But we found that the diversity of that data is somewhat limited. And there are various ways of doing it. One way of checking the diversity is maybe doing some kind of topic modeling, and we have done that internally. But even a very basic frequency distribution, this is taking about 10 million words from Common Crawl, which all of you are familiar with on the English side, and the Sangraha corpus, which we have created on the Hindi side. We took about 10 million words, so the same amount of content, and just looked at the frequency of the words. And what you find is that in the English side, you typically have a distribution which has a greater mass towards the tail, which means that there are a larger number of words for a given frequency for large amounts of this frequency. And this is in addition to the fact that a language like Hindi is more inflectional than a language like English. So there would be more word forms for a given noun or a verb in Hindi, and still you find that the tail typically is much more heavy in English. And as I said, this is further to the fact that the amount of data available in English itself is large. So being able to show a model that we built for Hindi or the many other languages in India, enough data about the world is something that remains as an open challenge, right? That is the second piece. The first one being lack of support. Second one is lack of somewhat very high quality data. The third one, again, quite familiar, I guess, to this audience, would be the number of tokens required to represent text. For example, if I took a sentence and its corresponding translation in Hindi and looked at the number of tokens it would take to do that representation, in all the existing models, whether it's Llama, Mistral, GPT, there's a significant, so to speak, tokenization tax, right? There are many more tokens on the Hindi side simply because these subwords are not modeled. Often it is just falling back on the Unicode characters and even sometimes incurring more than one token sometimes for the same character, right? So this is another important challenge. So that's the setting. You would like to be able to support Indian languages in models like Llama and Mistral and let people do things on top of it, but also avoid having to pay this tokenization cost. So how do we go about doing that? Just to formalize the problem a little bit more, let's say you have an English model and you would like to add Hindi skills onto it afterwards. And the goals are, of course, don't affect the English skills, don't spoil, don't have the forgetting that Siddhesh was focusing on. Secondly, of course, you want to have an efficient tokenizer for that language. You also need to be able to understand and generate what we are calling Romanized Hindi, because several people in India, especially on mobile phones, type Hindi not with the native script of Devanagari, but on the QWERTY keyboard in a Romanized script, and that is very, very common. So when chatting with friends, when even posting on social media, this is very important. The next thing is, of course, code mixing, which is, even if the script were to be the native script, you could combine English words with Hindi, and you need to be able to support that. And you need to be able to support cross-linguality very strongly. For example, if you have retrieval augmented generation, I might have documents in the English space, but I might have questions which are in Hindi, in Romanized form, or in code mixing. And also one thing to consider is that given how much these models have seen in the English world and how much knowledge they have there, unless we are able to translate huge amounts of text and show it also in Hindi, there is value in being able to think in English and respond in Hindi. And I'll show you some examples of this, right? So these are somehow the rough things that we would like to achieve. And the way we go about doing that is, of course, start from some base model. Let us say, in this case, Llama 2. We increase the vocabulary. We did some kind of an analysis. Let me again shift back here. The analysis was mainly from the point of view of taking about 100,000 documents from this corpus that we created and training a BPE-based tokenizer. And we managed to increase the tokenizer by about 16,000, going from the original 32,000 of the Llama model. And it turns out that if you do that, then about 70% of the Hindi words can be represented by a single token. This is especially true for things like news websites, which are usually simple language on the web. And sometimes it decreases when you do something like formal language, let's say the preamble, which comes from the Constitution of India, then the number of words which become single tokens reduces. And it is also somewhat lesser for things like Wikipedia. And if you have YouTube transcripts, which typically combine lots of English along with Hindi, so they are highly code mixed, the number of tokens which are complete words also decreases. But on the whole, we are able to reach, I don't think it's mentioned here, but a fertility score, which is, I think, of the order of 1.2, meaning most text is about 20 to 30% more number of tokens than there are words, right? And you see that difference show up here. If you do this efficient tokenization, then we are about 3 to 4x more efficient in terms of tokens than either the Llama tokenizer or the GPT tokenizer, right? So that is the first thing we do. We expand the vocabulary of the model. The next thing we do, this is somewhat non-standard. We teach the model to learn translation. This is not a pre-training task as such. Of course, it's a continual training setup, but this is a fine-tuning task wherein you show it content in one language, and then you ask it to translate it. So this is in the context of the prompt, and you're only backpropagating on the translation. So you essentially have attention masks which only send the backpropagation on the on one of the directions. And importantly, we only show original native text on the second direction. Meaning, if I had a pair of text, English, Hindi, where, let us say, Hindi is the original and English is the translation then we show English in the context and ask for the model to generate the native Hindi output, and the reverse as well, right? So because of the corpus that we have created, you could go and we do about 5 billion tokens of this kind. And we just train this model with the expanded vocabulary now to learn translation. And again, switching back here, you would find that if we did this, and it's a very phased way of doing training. So we call this phase 1, which is training the model to do translation. We see something interesting from an analysis point of view. If you took various tokens of various kinds, let's say verbs, animals, pronouns, and adjectives, initially we are randomly setting the embeddings, but the embeddings change after the first phase of this translation, and you clearly see that there are some kind of semantic clustering. This is the two principal components of the embeddings that is being visualized, and you can see that the pronouns form a different set. The verbs are completely different here. Then the adjectives are here, and so on. And this is back in the days when we were actually studying these neural networks and trying to interpret things a bit more closely. There was this whole area of birdology, which was trying to model, understand what's happening inside the bird. I think it's worthwhile doing that a bit more in these large language models as well. So the intention of the first phase was the model is capable of some amount of generation, but has also properly initialized the token embeddings, which are completely, of course, random to start with. The second phase that we do is to teach, again, something very non-standard. We teach the model what we call multilingual or bilingual next token prediction, wherein you show a sentence in English, then followed by a sentence in Hindi of the same document, where alternate sentences have been translated. Right? So let us say this was Shakespeare, then the first line of Shakespeare in English, and then the next line of Shakespeare in Hindi, the third line of Shakespeare again in English. So in some sense, we are doing next token prediction, in this case, trying to learn Shakespearean distribution of tokens, but also do that cross-lingually. Can you write the third sentence, knowing the first two sentences in English and Hindi respectively? So this pushes the model to do a few things. Firstly, we maintain a good ratio of tokens. It's always English and Hindi to the same proportion. But secondly, you want the model to be able to generate English given Hindi context and vice versa. So it's a harder objective to try and optimize for. And we did some experiments wherein we ablated doing monolingual training with this bilingual approach. And what we found was this is a plot here. On the y-axis is the loss, x-axis is the epoch of a particular SFT phase. So this is not phase 2. This is an SFT that we do after phase 2, where we just take the same amount of SFT data, and we found that the losses for two different pre-training phases. One had about 34 billion tokens from a highly curated data set that we created. Another had only 7 billion tokens in this alternate sentence format. And we found that the second one in the bilingual language modeling had in fact a lower loss. And we observed this a few times again and again. So I don't think this is a proven statement, but it's something really worth looking into. Can we look at more generalized forms of next token prediction, especially in the aid of multilinguality, right? And just for you to little bit see what this means graphically, I have here two similar sentences. I'll try to read and also translate, and also see what is the next token probability after the training. This is after training is completed. It says Bharat Vishwa Ka, that is India world of, and I can see what the next tokens are. It says Sabse, which is amongst all, right? That has the highest probability next token, and I can just continue going forward. The next word seems to be almost leading towards one particular token, and this continues. And after reaching a certain point, it is, of course, using the full stop, so to speak, in Hindi. And at this point, the model switches to generating English, and it continues like this, right? And what is interesting in these two examples is that there's a slight variant in the next one. In the first one, it says India was the largest democracy in the world, and then it continues with the country has a population of, because largest here is qualified by the number of people. So the English sentence is somehow able to identify the right next thing to say given the Hindi context. If I were to slightly change this setting, the context here, instead of saying India is the largest democracy, if you just give the statement as India is the seventh, this is the seventh as a word, and if you continue this, which is slightly different, firstly, Hindi is able to go to a different place and complete the sentence as India is the seventh largest country, in this case by size, right? Now by the land mass, and now it is able to continue in English and talk something about it is the second most populous country, right? So it is. So we have found in various places that it was able to cross-lingually attend to tokens and do a next token prediction, which is deriving both from English and Hindi past sentences. Okay, and of course the next phase. Going back to my slides, the next phase is some amount of fine tuning, and we have a cross-lingual fine-tuning data set, which contains things like writing long-form articles, doing summarization, translation, etc. And finally, there's also alignment that we propose. We don't discuss it in the blog, but one of the things that you could do is, in a model which is meant to be bilingual, you can ask the Hindi side to follow better what the English side does, because English is still doing quite well. And you could use things like direct preference optimization to make this alignment. So with it, it's somehow intra-model alignment between languages, right? Then I can then come and show you some of the benchmark numbers we had. We between our base model, which is this alt trans base model, and Llama, we do a comparison across the usual benchmarks. In the ARC benchmarks, we are slightly better, but we are worse on MMLU and HELASWAG, which are two important benchmarks themselves. One of the reasons for that is, of course, that the model itself is trained on this alt sentence, this bilingual modeling, and that is not very suitable directly for evaluation on a single language. But it's good to know that we haven't lost a whole lot of performance. On translation, this is an interesting piece of evaluation. We have here 4 different directions of translation. One is Hindi written in Devanagari script into English. Here we find that our model is of course, better than GPT 3.5 and GPT 4, but it is slightly behind domain-specific models. The domain-specific model here comes from the open source IndicTrans, which we had earlier trained, and also Google Translate itself. So from the Hindi to English side, there is a little bit of gap to domain-specific, better than GPT. But on English to Hindi, the model is already meeting the quality of open source domain-specific models and slightly trailing Google Translate, right? But the interesting thing also is that we are supporting Romanized Hindi. That is, you could write it using the QWERTY keyboard. And here you are finding that it, in fact, has an accuracy that is slightly better than using the Devanagari. It is much better than the GPT models, and current domain-specific models don't support it in either direction, right? So being able to make content accessible while using the Romanized form is something that we are also interested in. So firstly, this is one of the important things that Indian language AI is focused on, machine translation, and we are showing encouraging results even with very frugally trained model on top of Llama to 7 billion. Probably I didn't mention that this is Llama to 7 billion, and then very small amounts of training on top can get you to models which are fairly accurate. The other thing that we do, again, from an accessibility perspective, is do simplified translation. Maybe I can illustrate these things with a quick demo. So I'll just switch here to showing you some part of a video which contains some different tasks with this model. I'm going to mute that. So one of the examples, I hope you're able to see this. One of the examples is asking the model to write an essay about the natural beauty and diversity of India. It, of course, formulates a reasonable answer. So fluency in Hindi seems decent. And of course, the tokenizer is also quite efficient. If we go ahead here, the tokenizer was ending with few hundred tokens. But if I took the same text and I pasted it in GPT output, you would see that it is 4-5x greater number of tokens, right? So that was what we already discussed. This is the write in English, generate in Hindi setting. When we do something like, okay, when we ask the model to simulate a conversation between Harry Potter, a fictional character, and Hanuman, a mythological character, it tends to do better when it thinks in English and writes it. And the model is able to translate this quite well, preserving the structure, the format, etc., and generate an output in Hindi. So this might be a useful mode to do inferencing in some of these frugally created bilingual models. Another example is cross-lingual RAG, which is when you could take content, let us say in this case, content from a textbook, which is in English, and somebody puts that into the context and then is able to ask questions around it. But you can ask the questions in a cross-lingual way. I could say constellation kya hai, which means what is a constellation, and is being answered based on that. You can also ask questions in the Devanagari script, which also gets answered. And we've also done some amount of grounding wherein if the passage does not contain something, it says it's not possible. This is useful for the education use case. This is also useful for e-governance. We have another example where the people are trying to access legal content and find this to be a better way of accessing it. We also do fairly well on summarization, cross-lingual summarization. I'm not able to show it here, but what we have done is pasted this whole Bletchley statement that came out in the AI summit, and then we ask it to be summarized in Hindi in a few bullet points, and it does a fairly good job of cross-lingual summarization. The other thing worth discussing is translation. Of course, it is able to translate from English to Hindi. Interestingly, it is not tripping on things like citation numbers, sometimes domain-specific models too. It also learns to maintain specific parts of the text in English. So this is, again, the advantages of these generative models. They learn skills that are more useful in these corner cases than domain-specific models. Interestingly, what also we've found on the translation side is if you took a sentence, this is a sentence from OpenAI's paper on GPT-4, if you literally translated this particular sentence, you end up with lots of complex words in Hindi, which are very complex for people to understand. But you could do something like say that you translate the above to Hindi, analyze the complexity, and then simplify it. So here it gives me a literal translation. And then in English, you can sort of try to understand what are the complex pieces, benchmark specific training or hand engineering is complex and so on. And then the model can generate a simplified translation. It turns out that what it generates little bit loses the exact meaning, but it is definitely more easier to use. For example, there is the word customization that it writes here for hand engineered was the original word, right? So it does some of that. And I think this is an interesting direction for us to explore more formally as a community on how to translate and make things accessible. The final piece is the Roman content support, the Romanized input support rather. People tend to write like this. This is a sentence which says that my parcel has not arrived. I have been waiting for a long time and now want to cancel the order with full refund. And this is well supported, right? So I think that is something that works. And just final thing that I wanted to show quickly was it also allows a translation from Hindi to English. But interestingly, this works out even if if I removed some spaces in the input Hindi, that is, you corrupted the Hindi input, but still it's able to generate the right output. And this may be useful, especially when there are typos, but also in OCR, which in Indian languages tends to make mistakes in terms of inserting spaces and so on. So I'll stop with that. Broadly, we just proposed a method wherein frugally you are able to add a new language to an existing base model. As base models keep improving, you get mixture of expert models, larger models, etc., and you have so many languages to add support to. This is something worth considering and exploring more formally. Thank you.